Hello kids, this is an algebra review lesson on solving linear systems. We're going to solve 3x3 systems. Next is our next objective, so I wanted to do a review of 2x2 systems, and your homework tonight is a handout on the same. So, to solve linear systems, firstly, we're dealing with lines. In later units, we will solve systems, and they won't just be lines. And the word system just means that you have more than one at the same time. Your goal is to find the point, if any, where two lines intersect, which algebraically means you find the point that makes both equations true at the same time. So this is, if you want to think about it, a graphical approach. Graphically, see two lines cross. Algebraically, you have the point xy that you plug in both equations at the same time, and you see equality. Both equations are true with the same point. Graphically, both lines cross, and you see the intersection. We can achieve this goal, of course, graphically by hand or by calculator, and that's usually an estimate. The add-down method, students like, and hopefully you remember that from Algebra 1. It only works, though, under certain conditions. The synonym, or the other name for the add-down method, is called the linear combinations. The add-down method is something we actually did, just not with the goal of solving. This is where we took function f plus g of x, right? It's where you take two functions and you add them. We had mom, we dad, and we got the child, f plus g, remember? So in adding just means you combine like terms, right? In Algebra 1, students usually like linear combinations because you're working with all nice numbers. Substitution is also a method. What's nice about substitution, it always works. I don't even have to have lines to use substitution. Sometimes kids don't like it as much because the algebra can give you some fractions and things, and they're like, oh no! But we know fractions are okay, right? Simultaneous linear systems is another vocabulary word. Simultaneous just means that you're looking at the lines together. For now, you'll be dealing with just systems of two lines. And remember, the solutions will look like a point. Or sometimes you will get no solution when your lines are parallel, or they're coinciding. Those two lines are not coinciding. Now they are. Coinciding just means they are the same line. Notice, though, that my solution looks like a point when I solve a system, or it looks like a null set. Of course, you can also write no solution. Or your solution looks like an equation. If all your points are found in one place, I need to know where they're found, and that's the equation of the line. Vocabulary again. IB calls intersecting lines an independent consistent system. If you have no solution, it's an inconsistent system. If you have the same line, well, it's a consistent system because you have an answer, but you have infinite answers. So it depends on being the same line, so it's called a dependent consistent system. Again, independent means one unique solution. Inconsistent system means you have no solution. Dependent consistent means you have infinite solutions, but those infinite solutions are found on one line. So they are telling me to use substitution, so I must. Even if I really want to use add down, I have to use substitution. I could get this y by itself, this x by itself, or this y by itself, but I be more efficient if I choose this x to be by itself. Since x is 6 plus 8y, go to the next equation and replace x. And I get 5 times 6 plus 8y plus 8y is equal to 0. Notice that I had two equations here. This is called a 2 by 2 system because you have two equations and two unknowns, or two different kinds of variables. And notice I have reduced it. I've taken a 2 by 2 system and I've morphed it into a 1 by 1. One equation with only one unknown. Now I just do algebra. Probably will help my math to turn that into negative 5 over 6. 5 over 6 goes into 35 times 6 goes into 48. 8 times 30. Alright, I now know that I have a y for a solution. I already know what type of system this is. I'm going to get an x, so I'm going to get one point of intersection. So this is an independent, consistent system. The graph of this would look like intersecting lines. I just have to go find the x. I have to go find the x when y is negative 5/8. So, when y is negative 5/8, I can go to this equation, plug in negative 5/8 and solve for x. This equation, plug in negative 5/8 and solve for x. Or, why wouldn't I go here? Because x is already by itself. So if I take this negative 5/8, plop it here, then I can solve for x, and I will get one. Now, of course, I'm just waiting for my taskbar to go away so that I can get my pen back. There we go. Okay. So again, I'm going to plug into, so what is x when y is negative 5/8? X is equal to 6 minus 5, which is 1. So, if again they had not told me to use substitution, I don't know that I would have used substitution. I think I probably would have used the add down method, since function 1 and function 2 are both in standard form, and all my x's and y's line up nicely. And further, when I take two functions and add them together, I have 1x and 5x, which gives me, let me erase everything here. If I add these together, 5x and 1x is 6x. And look at this nice situation. Negative 8 plus 8 is 0. Is equal to 6, and shockingly x is equal to 1, which I already knew. Then I take this x and go back and plug it into a y, so I can plug it either place. Since the first equation has fewer or lower coefficients, this coefficient being 1 instead of 5, I think I'll put 1 minus 8y is equal to 6. And shocker, y is equal to negative 5/8. And probably it would have been more efficient to recognize that linear combinations would have been a simpler choice. Unfortunately, I didn't have a choice. They told me to use substitution. But sometimes an assessment just says solve, so you choose. And knowing when to choose substitution and when to choose linear combinations can just help speed up your assessment. So let's do this one. Use linear combinations to solve a different system. So now again, I don't have a choice. They're telling me to use linear combinations. I'm going to add down. Remember, I have a 2 by 2 system. 2x and 2x is 4x. Negative 3 and negative 3 is negative 6x. 7 and negative 4 is 3. Now I have done a completely legal math. Totally legal. But have I helped myself? Oops, sorry, this is a y. I had 2 variables. Don't I still have 2 variables? Grr. So, I did legal math, I did linear combinations, it just didn't get me what I wanted. Watch this magic. I'm going to multiply to get rid of one variable. So I choose to multiply the first equation of all the numbers in all the world, I choose to multiply it by negative 1. So I'll take this equation, multiply it by negative 1, which means I now have negative 2x plus 3y is equal to negative 7. Then I just bring this one over, and I get 2x minus 3y is equal to negative 4. And now I add down. And now look at that. I'm so happy the x's are going to go away. I get 0 x's and... okay. When I add down the y's, I get 0 as well, meaning the whole left side is 0. And the whole right side is negative 11. Think. The math is talking to you. You were looking, you were doing this math. I was looking for a point of intersection. And my math told me nonsense. Right? I was looking for a point of intersection, I did math, and my math gave me a false statement. 0 is certainly not equal to negative 11. What do you think the math is saying? What you were looking for does not exist. So what type of system is this? Inconsistent. I found no answer. Which means what kind of lines did I have? That's right. Parallel. What is my algebra telling me? Alright, let's go back to another system. Here's a different system, and notice that it changed again. What must I use? Right? I don't get a choice. They're telling me to use substitution. So as I'm doing this heinous erasing here, I really want to erase all ink on this slide. There we go. What I could get any variable by itself. Which one do you think we should choose? Okay. I also would choose that one. So get y by itself. Waiting. So my taskbar goes away. There we go. Oops, did not move. So I'm going to get y by itself. Y is equal to 2x minus 3 take this y, substitute it back into the other equation. Notice this is a 2 by 2 system. I want a 1 by 1. One equation, one unknown. If I take 8x minus 4 times y, I have only x's. One equation with only one variable. Oh, hey, my x's dropped away. 8x minus 8x is 0, leaving me with, hey, no variables again. But did you get 0 equals negative 11? No, you got equality. You got a true statement. True no matter what x and y you use. What does that mean? That means that you have the same line. Coinciding lines which means you have a consistent system but it depends on you having the same line. So dependent consistent system. Please do not write infinity here. I know there are infinity answers, but where are the answers? Where can I find the solution? It's not one point and it's not null set. It's an equation. Which one? You can write equation 1, you can write equation 2, or you can write equation 3 because all the equations are the same. That's the point. Get it? That's my solution. Oops, sorry. So your homework tonight is an Algebra 1 handout with a bunch of systems to solve, all nice little integer coefficients, and sometimes your point of intersection will be integers, sometimes there'll be some rational numbers or some fractions. Other times you'll get no solution, and other times you'll get infinite solutions, meaning you write an equation. And then tomorrow we will go on to larger systems, 3 by 3 systems. Have a good one. See ya.